Good morning, everyone. So, in this lesson, we're going to go over L'Hospital's rule and the different indeterminate forms you need to be familiar with. We will have sufficient examples so you can master this topic. So, for your learning outcomes, at the end of the lesson, you should be able to recognize when to apply L'Hospital's rule and calculate limits using L'Hospital's rule. So, let's begin. So, let's say if you want to find the limit of f of x divided by g of x as x approaches a, and let's say that this function is in the form 0 over 0 or infinity over infinity. So these are known as indeterminate forms. Because what exactly is 0 divided by 0? 0 divided by 5, for example, is equal to 0. 1 divided by 0 is undefined. So what exactly is 0 divided by 0? We don't know. Infinity divided by infinity could be constant like 4, it could be 1, it could be infinity, it could be 0. We just don't know the value of it. So they are indeterminate. So let's say that the limit of f of x is 0 and g of x is also 0 as x approaches a. So we would have the indeterminate forms 0 over 0. If that's the case, if we have infinity over infinity, then this limit is equal to the limit of f prime of x divided by g prime of x as x approaches a. And that's the basic idea of L'Hospital's rule. So if you can't find the limit in this form, so kung hindi mahanap yung limit gamit itong form na to, take the derivative of the numerator and the denominator separately and you might be able to find the derivative. Now this is going to make sense once we do a few examples. So let's try an example. So what is the limit of e raised to x divided by x squared as x approaches infinity? So let's see if we could use direct substitution first. So we substituted x with infinity. So we have e raised to infinity divided by infinity squared. So what is e raised to infinity? E raised to infinity is going to be a large number. So it's infinity. Infinity squared is also infinity. So what we have here is an indeterminate form, which means that we can use L'Hospital's rule to figure this out. Because right now we don't know what that is. Okay, so now if you plug in numbers, you can also find out the answer. So let's say mag-substitute tayo ng large number, for example, 100. So kung ita-type natin yan sa calculator, e raised to 100 divided by 100 square, that will be a very large number. So it's 2.688 times 10 raised to 39. So direct substitution is just like your fallback method. Anytime you're having difficulty finding the answer, this technique will always work. So if you plug this in, this large number represents infinity. So infinity is the answer. But let's use L'Hospital's rule to find out the answer. So ang gagawin natin is to take the derivative of the numerator and the denominator separately. So we have the limit as x approaches infinity of e raised to x d over dx. So kukunin yung derivative ng e raised to x, kukunin din yung derivative ng x square. So the derivative of the numerator e raised to x is simply e raised to x. and then the derivative of x squared is 2x. Okay, so now if we plug in infinity at this point, it's still going to be infinity over infinity. So e raised to infinity is infinity, and then 2 times infinity is still infinity. So we still have the indeterminate form. So we can use the L'Hospital's rule for the second time. So kukunin ulit natin yung limit ng e raised to x, yung numerator, and then yung the derivative of e raised to x, and then the derivative of 2x. So the derivative of e raised to x is of course still e raised to x, and then the derivative of 2x is equal to 2. So notice that we no longer have the indeterminate form. So if we replace x with infinity, it's going to be infinity divided by 2, which is infinity. And that will be the final answer. So, plug in natin yung infinity, replacing x. So, e raised to infinity divided by 2. E raised to infinity is equal to infinity divided by 2, which is equal to infinity. Let's have another example. So, what is the limit of sine x divided by x as x approaches 0? So if we substitute 0, we're going to have sine of 0 divided by 0. Sine of 0 is 0. So that's going to be 0 divided by 0. And that's an indeterminate form. And we don't know what that is equal to. It could be 0, it could be infinity, it could be 5 or 1. We just don't know. But we can use L'Hospital's rule. But before we do that, let's plug in a number which is very close to 0. At tignan natin kung ano yung magiging sagot. So kung mag-substitute tayo ng number na malapit sa 0, let's say 0.001. So we have the limit of sine 0.001 divided by 0.001 as x approaches 0. So ang sagot dyan ay 0.99999. Okay, so now tignan naman natin kung anong mangyayari kung mag-substitute tayo ng mas mababa pang number. So, let's say we have 0.00001. So, sine of 0.00001 divided by 0.00001 is equal to 1. Okay, so now there are two things that can happen at this point. So, either the number can stay the same or pwede ring magbago. So, as you can see, the number stays the same, 0.99999 and 1. So if it stays the same, then that's going to be the limit. So ibig sabihin, ito na yung limit natin, 1. If it gets smaller, then the limit is 0. Kung bumaba sana, yung limit ay 0. If it gets larger, then it is something else. So the calculator gives us 1, so we know that this is the answer. But let's use L'Hospital's rule to confirm the answer. So let's differentiate the numerator and the denominator separately. So ang derivative ng sine x ay cosine x. And then the derivative of the denominator x is 1. So we have the limit of cosine x over 1 as x approaches 0. So at this point, we can substitute 0. So cosine of 0 divided by 1. Cosine of 0 is 1. So 1 divided by 1 is equal to 1. So as you can see, L'Hospital's rule works. If it will give you the right answer as long as you have an indeterminate form. So let's try another example. So what's the limit of ln x over x as x approaches infinity? So if we substitute infinity at this point, the natural logarithm of infinity is infinity, divided by infinity. So we have the indeterminate form infinity over infinity, which means we can use the L'Hospital's rule to get the answer. So first, let's plug in a number which is close to infinity. Let's say 1000. So this is equal to the natural logarithm of 1000 divided by 1000 is equal to 0.0069, which is close to 0. So let's try a larger number. Let's say 1 million. So the natural logarithm of 1 million divided by 1 million is equal to 0.00000138. So therefore, we could say that the limit is approaching 0. Okay, so let's use L'Hospital's rule to confirm the answer. So let's differentiate the numerator and the denominator separately. So ang derivative ng ln x ay 1 over x, and then ang derivative ng x ay 1. So we have the limit of 1 over x divided by 1 as x approaches infinity. So 1 over x divided by 1 is just 1 over x. The limit of 1 over x as x approaches infinity. So we can now plug in infinity replacing x. So we have that's equal to 1 over infinity, which is equal to 0. So whenever you have a large number in the denominator, so infinity is a large number, it's always 0. Anytime you divide by a large number, you're going to get a small number. Let's have example number 4. So what is the limit of sine x over x as x approaches infinity? So now this is not 0, by the way. This is infinity. And so when x approaches infinity, you need to consider the end behavior of the function. Now sine x is simply a function which repeats, whereas the function for x, it increases. So x increases at a rate which is greater than the sine. X increases at a greater rate than the sine. Therefore, we can say that the function is bottom heavy. This technique only applies if x approaches a very large number, either infinity or negative infinity. So it doesn't work if x approaches 0 or some constant. So since we know that it's bottom heavy, since x increases a greater rate than sine x, we know that the final answer is going to be 0. So if you plug in a large number into the equation, let's say 1000, make sure that your calculator is in region mode. So sine of 1000 divided by 1000, that will give you 0.00083. So it works. So let's confirm the answer using L'Hospital's rule. Actually, can we use L'Hospital's rule in this particular problem? It turns out na hindi natin pwedeng gamitin yung L'Hospital's rule. Sine infinity over infinity is not an indeterminate form. Sine infinity vary between -1 to +1 divided by infinity, so that's definitely going to be 0. So anytime you have a constant divided by infinity, it's always equal to 0. So L'Hospital's rule doesn't work for this equation. We don't have an indeterminate form. Nevertheless, malalaman pa rin natin kung ano yung tamang sagot. Okay, so let's try another example. So what is the limit of x squared plus x minus 6 divided by x squared minus 2x as x approaches positive 2. So does L'Hospital's rule work for this particular example? So let's find out. So let's plug in 2. So the limit of x squared plus x minus 6 divided by x squared minus 2x as x approaches 2 is equal to, so ipa-plug in natin yung 2 for x. So we have 2 squared plus 2 minus 6 divided by 2 squared minus 2 times 2. So 2 squared is 4. So that's 4 plus 2 minus 6. And then 2 square here in the denominator is also 4. Minus 2 times 2 is 4. So 4 plus 2 is 6. Minus 6 is 0. Divided by 4 minus 4 is also 0. So we have the indeterminate form 0 over 0, which means that L'Hospital's rule can work in this problem. Okay, so now let's differentiate, or let's get the derivative of the numerator and the denominator. So, ang derivative ng x square ay 2x. The derivative of x is 1. The derivative of negative 6, since this is a constant, is 0. Here in the denominator, the derivative of x square is 2x. The derivative of negative 2x is negative 2. And then, kapag plinag-in natin yung 2 dito, so we have 2 times 2 plus 1 divided by 2 times 2 minus 2. So 2 times 2 is 4 plus 1, that's 5. 2 times 2 is 4 minus 2 is equal to 2. So the final answer is 5 halves, or 5 over 2. Okay, so another way in which that we can get the same answer is by factoring. So if factor natin yung nasa numerator and denominator. So as you can see, dito sa numerator, it's a trinomial which can be factored into product of two binomials. So the coefficient of the first term in the numerator is 1. And then the constant term is negative 6. So you consider the terms, the factors of negative 6, we have 3 and negative 2. So the factors of the numerator are x plus 3 and x minus 2. Dito naman sa denominator part, finactor out natin yung GCF, or greatest common factor, which is x. So the factors of the denominator is x times x minus 2. So we can see that x minus 2 can be eliminated. So ang matitira na lang ay the limit of x plus 3 divided by x as x approaches 2. And then, plinag in natin yung 2 dito sa resulting equation. So we have the limit of 2 plus 3 over 2 as x approaches 2 is equal to 5 halves. So as you can see, the answers are the same. So let's have our last example. So what is the limit of 5 plus x cubed divided by x squared plus 4 as x approaches infinity? So the most significant term in the numerator is x cubed, and the most significant term in the denominator is x squared. X cubed increases at a faster rate than x squared. So therefore, the function is top heavy, which means that the limit could be positive or negative infinity, but it's probably going to be positive infinity. So if we could plug in infinity right now, it is going to be, so plinag in natin yung infinity, replacing x. So we have the limit of 5 plus infinity cube divided by infinity square plus 4 as x approaches infinity. So 5 plus infinity cube is infinity. Infinity square plus 4 is infinity. So we can use L'Hospital's rule at this point since we have an indeterminate form. So let's find out the derivative of the numerator and denominator. So I'm using this notation to indicate that I am finding for the derivative. So here in the numerator, the derivative of 5 is 0. The derivative of x cubed is 3x squared. Here in the denominator, the derivative of x squared is 2x. The derivative of 4 is 0. So if we plug in infinity, we will have 3 times infinity squared divided by 2 times infinity. So we will have still an indeterminate form. So infinity over infinity pa rin. So we can use L'Hospital's rule one more time. Okay, so dito sa limit of 3x squared over 2x as x approaches infinity, kukunin pa rin ulit natin yung derivative ng numerator and denominator. So the derivative of 3x squared is 6x. The derivative of 2x is 2. So as you can see, wala na tayong indeterminate form. So 6x divided by 2, that will be 3x. So we have the limit of 3x as x approaches infinity. So ipa-plug in na natin yung infinity dito sa 3x. So we have that's equal to 3 times infinity, which is equal to infinity. So as you can see, whenever you have a top-heavy function or whenever the numerator, gaya dito sa example natin, x cubed dito sa numerator, x squared dito sa denominator. So that's a top-heavy function. So whenever the numerator increases at a greater rate than the denominator, assuming if x approaches a large number, the answer will always be infinity. If it's bottom heavy, where the denominator increases at a greater rate than the numerator when x approaches a large number, it is going to be 0.